All right, the last one that we have to do is the last convergent plate boundary, and that's looking at oceanic to oceanic. So this one, there's a little bit more information, but really with these subduction zones, we looked at divergent plate boundaries, and that's where you have the plates moving away from each other, and that's where you have almost like new plate material that's getting, in quotations, created, right? So that's where the magma is seeping up, filling in, the cracks that are in the plates, between the plates, and you're almost getting like new material. With subduction zones, this is actually where it seems as if the plate material is almost getting destroyed, right? And I do put that in quotations because one thing we learned in the energy unit is that thing, especially in terms of like matter, you don't create, or energy, we can't create energy or destroy energy. We also get into this idea of plate material, right? So you don't create, in quotations, make brand new plate material, or you don't destroy it, it actually just gets recycled. And this is something we're going to look at a little bit later, but I just want to bring this idea up because it's extremely important when it comes to basically what we're doing. And so that occurs in areas that are subduction zones. So that could be the oceanic to continental convergent plate boundary, but it also takes place with oceanic to oceanic. Now, some of you might be thinking with oceanic to oceanic convergent plate boundaries that we have the same type of crust. So you would kind of expect, since it's the same, and you would think that the densities are the same, that you should just simply get mountains. This is a case where you have oceanic crust and oceanic crust that are moving toward each other, but they actually have different densities, right? So that can take place, right? If the age of the rock is different, the density is going to be different as well. So this information is looking here. And again, you can pause the video when you need to fill this information in. So it says, as two plates with different densities move toward each other and they collide, the older one that's more dense, which is the oceanic crust, is going to sink beneath the younger one that's actually less dense. And that's going to create, you can get things like islands in this situation. Those islands could be volcanoes as well. But also, more importantly, we also get those trenches. Right? And it almost seems as if that plate material is getting destroyed, right? Because it's going into the mantle, it's becoming part of the mantle, and it's becoming that molten rock or more liquid than solid. But it's really just getting heated up. We'll talk about that idea later. So go ahead and pause the video. The main things to include here is making sure that we talk about islands, right? Because when we do see those islands, typically we're looking more at oceanic to oceanic, right? Because again, even though it's basically the islands are just mountain areas, you do have part of that that's actually covered in water, so they're islands. So also make sure we can represent it with volcanoes with the red dots. And then you have, and I don't really like that I call this the ocean plate. It really should just be the oceanic crust, because a plate could be made up of continental and oceanic. But either way, it'll work for now. So you have them going toward each other. Make sure you include the idea of trenches in your drawing as well. If we look at the Plato plates, this is where we do have to represent their thicknesses close to the same, but one could, and the reason why is because we're looking at oceanic, right? But their densities can still be different. And if their densities are different, that's where you get subduction, and that's where you actually get volcanoes being created. Because you don't really get volcanoes if you don't have subduction, although there is a case where you can, but we'll talk about that later. So mainly subduction is where you actually see volcanoes. So we have this one is going to be the more dense crust. This one's going to be the less dense. And so when these two plates collide, this one's going to rise up, kind of crumple and fold a little bit, get those mountains, which are islands because it's all covered in water. And then the other one's going to subduct. It's going to become part of the mantle. It's going to get heated by the mantle, and it's going to become more like a liquid instead of a solid, right? But then that can rise upwards too, creating volcanoes. We will look at volcanoes in the next lesson. Okay, let's look at a real life example. So if we go to Google Maps, again, this is where, so if you're trying to search for an area where you actually see oceanic to oceanic convergent plate boundaries, you don't want to look for an area with continents, right? Because really this, like where so you want to look for a trench, which is that dark blue area. But if you have a continent there, that's telling you it's actually continental to oceanic plate boundaries. right? So this would be more like you could have a little bit of oceanic here, but these are continents, so let's actually be continental. We see how we don't see the trenches here anymore because that's a transformed plate boundary. And I'm hoping we can see the Aleutian Islands because it's kind of covered in clouds. But if we scroll here, it's a little covered in clouds, so I do apologize. You can start seeing this dark blue area, and we don't have continents, although you could actually get islands. So this is looking at the area of the Aleutian Islands, and it's actually the Aleutian Islands are more there. It's just a little hidden by the clouds. So, but you can see that dark blue area, that's telling you there's a trench. Oh, there's the Aleutian Islands, right? So we have a trench that's there, and those Aleutian Islands get created because you have you have oceanic crust moving in this direction, oceanic crust moving in this direction. They're going to collide. One is going to be more dense. It looks like this one's actually the more dense one. You can see it's a little bit thicker, the higher elevation. This one looks like it's going to be the less dense one, and this one's going to subduct underneath that one because it's, I think I said that wrong. I apologize. I don't know if I said this right or not. This one's more dense because it's going to subduct underneath that one. This one is less dense because it's going up. If I said that wrong, I apologize before. But so this one is the more dense crust. This one is the less dense crust. And we see those, those mountains getting created, or technically the islands, because they're then surrounded by water. But it's pretty cool how we can actually see that on here. Let's see if we can travel to the Aleutian Islands. I don't, darn, we're not going to be able to. That is a little upsetting, but we can zoom in. Let's see how far we can zoom in. Right, so you can see the Aleutian Islands a little bit better. So it's pretty neat that we can actually see the areas of high elevation. So it's going to be a very deep valley. I mean, even look at this, just those areas. This is the Bering Sea. It's a little bit different, but it's pretty cool what you can actually see on the Google Maps. And, even looking at the islands here. So it's like, and if you think about all the other areas on Earth, some of those areas are pretty easy to explain in terms of the plate boundaries that you're seeing. And we're kind of going to do this tomorrow. But some of them are really hard to explain. And one of them that you guys can start thinking about, oh, sorry, let me bring this up really quick while I'm here. This is looking at, in the reading you have to do, oh, looks like a little hurricane. Sorry. In the reading you have to do about the Ring of Fire, right? So this is looking at the area that's Ring of Fire. You have a lot of earthquakes that take place there. So that's kind of looking at this area here, just to kind of let you know. But let's go back to, I'm trying to get to North America. I guess I should have went the other way around. It would have been faster. It's still cool how you can see all the different elevations. Okay, that should be south. One that's kind of a strange one to bring up, and I don't know if we're going to have time to talk about this or not, the Rocky Mountains. That one's kind of a weird idea to think about because, again, we have this occurring in the middle of a continent. And when we start looking at the directions in which the plates are moving, you guys might get a little puzzled at this idea because there are some strange things that are taking place here. Another strange one, and again, I don't know if we'll be able to talk about it, but that's looking in Africa at the Red Sea, right? And actually, even like the Horn of Africa, this area, some really strange things are happening in terms of the plate boundaries. But for the most part, you should be able to look at the different areas on Earth and predict what type of plate boundaries are actually located in those areas. That's exactly what scientists did, right? And then they looked at the direction in which these plates are moving. We're going to kind of do the same things. That's the point. So hopefully these videos were helpful. That is my last one. Make sure you get that reading 5.1 done as well, because that's looking at the Ring of Fire and kind of the idea with the earthquakes and everything, and it helps explain some of those ideas. So thanks.